All right, so like I said, I wanted to add on a little bit to our unit circle today. Little cheat sheet, study guide, whatever you want to say here. All right, what we're going to add today will be our, I guess we could have added like SOHCAHTOA and stuff like that. But anyway, we can add that in there if you want to. But more importantly, I think we have that down. But I think we do need to kind of review the special right triangles.
But we didn't get a paper of this. Should we just do that anywhere in your book?
Oh, I see. You just add on to it. Yeah, or you just, like squeeze it in there somewhere. I would say wherever you can fit it. You know, because I'm not gonna fill this up, Ethan. I won't fill this up. So I mean, you'll have you know, shouldn't be too bad. Okay. So special right triangles. Here we go. What we're gonna have, right, are the 30, 60, 90. Okay, and then the 45, 45, 90. Okay. And again, these are kind of special, or we kind of like pull these out because they are, we can easily derive what their measures are, both sides and angles, okay, which is kind of special because oftentimes we can come up with nice angles for a right triangle, but then the sides will be like, you know, decimals and weird and stuff like that. Or you can come up with nice nice sides, but then the angles will be like decimals and like hard to understand and stuff like that. But for these two special right triangles, because of their natures, you get the 30, 60, 90 by taking an equilateral triangle and cutting it in half. All right, and you get the 45, 45, 90. Well, it's just an isosceles right triangle. So you can, by those two properties, it's easy to kind of derive what their side measures are, and of course the angles work out kind of nicely too. Okay, so that's kind of why I think we do this kind of stuff. I could just be making that up though, so, but that's my opinion. All right, about why we do this. Okay, so in a 30, 60, 90 right triangle, okay, the sides are always in the same ratio of one another, right? So, or sorry, the sides are always in the same ratio, so they could be, well, you know, there's similarity that come into play here. The setup we're going to use for our 30, 60, 90 right triangle, though, is going to be this. Okay, we'll say that this is 1, that's 2, and then that's root 3. Okay, just to make life easy for ourselves. Yeah. Yep. Okay. But of course, there are an infinite number of 30, 60, 90 right triangles. They would just be, you know, multiples of 2 root 3 to the 1 there. Okay. But things to keep in mind here, right? The leg that's 1, okay, the leg that is 1 is opposite the 30-degree angle. How can we know that? Well, because the smallest angle is always opposite the smallest side in a triangle, right? And then the next biggest side is root 3, that's opposite the 60-degree angle. And then the biggest side is 2, and that is opposite the 90-degree angle. Okay? So the hypotenuse is going to always be twice that shorter leg, and then we have root 3 for the other leg. Okay? And then for the 45, 45, 90, try to make it look different, but it doesn't really look that much different. Oh well. You'll just have to take my word for it. Okay. In this case, all right, I'm going to change it up. Just, let's see, do I want to use the... There's like different ways to set this one up, and I'm not so... Does anyone that was in Thompson's class, what do you show you guys? Do you guys remember?
There was 2 ways.
Yeah. So you could do it this way, basically. You can do 1, 1, and then root 2. Or if you want to, or you could do root 2, and then this would be just or 2. Okay. So let's see here. I'll put the other options in parentheses here, parenthetically. Okay. I think I tend to use the 1 and the root 2, but you could do it. You could do it with the root 2's, and the 2. Okay. Again, really, there's an infinite number of ways to set up the 45, 45, 90. Just again, just by similarity, right? You can multiply all the sides by 3. You can multiply all the sides by square root of, you know, pi if you wanted to. The reason why we set them up in these particular ways is because it just kind of makes the trig ratios a little bit easier to work with. Okay. You may remember, for example, the 30, 60, 90 as being 1 for the hypotenuse, 1/2 for the leg, short leg, and then root 3 over 2 for the long leg. Okay, stuff like that. Okay, but it just depends on how it's taught. But these are the better ways to remember them, I would say. Okay. So there's our special right triangles, helpful to use. These will be kind of like one strategy that you'll be able to use, and I'll show you this later too. But this is one potential strategy you can use to help you when it comes to evaluating angles on the unit circle. Okay, or help you like simplifying the stuff we're going to, again, our end goal of being able to evaluate sine, cosine, tangent, secant, or cosecant, secant, and cotangent of any angle on the unit circle. Okay, that's our end goal here, is to take any 6 of our trig functions and be able to evaluate any one of these angles mentally without our calculators. Okay, so, but that's where it's going to start. You can either use this, or some people just remember the position on the unit circle. So it goes different ways there. All right, so that's there for you. Okay, and you might want to keep that handy. I'm going to put mine away for right now, but I have it handy just in case. And let's get into that what we're going to do today. So you can turn then to another page. And so using those special right triangles, we're now going to add coordinates on the unit circle. Okay? Because remember, our unit circle here, it exists in the coordinate plane, right? This is the x-axis, that's the y-axis. The unit circle is a circle centered at the origin, right, with a radius of 1. As Jeff was telling us, I think yesterday or 2 days ago, right? Unit stands for the 1. Okay? So that's our circle right there. And so we're going to try and locate then what the coordinates would be of some of these points that our angles help us find, right? So for example, you know, at 0 degrees, what would the coordinate of this point have to be, right? At pi over 6 on the unit circle here, or 30 degrees, right? What would this coordinate have to be? At 45, at 60, at 90, what would those coordinates have to be? Okay? We're going to use that to help us out. Okay, so in order to do that, let's kind of take a look here at our unit circle, and I'm going to kind of like start in quadrant 1. So what we'll do is I'll kind of like zoom in on just one section of our unit circle, the first quadrant. Okay, so I'm just going to draw like a quarter of a circle here, something like that. Not great, but oh well. Okay, there's our x-axis, there's our y-axis. Okay, and so on that unit circle, right, we have, well, our first point that we kind of come across is this one right here at 0 degrees or at 360. Now this one is an easy one to determine the coordinates of this one. What's the coordinate of this point going to be? 1, 0, right? If this is a circle of radius 1, and we're exactly 1 unit to the right here on the x-axis, the coordinate then will be exactly, 1, 0. Okay? So that's pretty easy, pretty straightforward. But then what about if we want to do something, well, the next angle we come across would be like this one right here, and that would be when we're at pi over 6, or you could say 60 degrees, Mr. Wade, come on, 30 degrees. Okay? So we have this point right here, and we want to figure out what are the coordinates, the x and y coordinates of this point. Well, we know the x coordinate is going to be a little bit less than 1, right, because we've moved a little bit to the left, and our y coordinate is going to be more than 0 because we've definitely moved up some from there too. But finding the exact coordinates, well, that's going to be a little bit tricky. But if I kind of drop a vertical line down there, okay, again, what we're trying to find would be the x coordinate. So from the origin, we want to figure out what this distance is, right? That horizontal distance. And then as well, we want to figure out off the x-axis what this y distance is as well. And that will give us our coordinate there, right? What kind of shape have I created by kind of drawing this? Yeah, a triangle, and specifically what kind of triangle? A right triangle and a 30, 60, 90, even more specifically to that. Exactly right. So let's take this 30, 60, 90 right here, and let's kind of label some things. What do we know about it? Well, if this angle right here is 30 or pi over 6, well, we have a right angle right here, because again, the y and the x there meet at a right angle. And this is going to be 60, yeah. Or pi over 3 if you like. But we'll just leave it as 60 for right now. What other information do we know about this right triangle? What's the hypotenuse distance going to be? 1. How do we know that? because it's a radius. Yeah, it's a radius of that unit circle, right? It goes from the center of the circle to a point on the circle. So we'll say radius of 1. Okay? Because this is the unit circle, right? So the unit circle is centered at the origin with a radius of 1. So we have the hypotenuse here, which joins the center of the circle, the origin, to a point on the circle. So that's a radius of the circle.
Did you just tell us that the radius is 1?
Well, so the fact that this thing is a unit circle, right, means that that's what it is. The radius is 1 for the thing. Yeah. Yep, radius of the unit circle is 1. Yes, Jeff.
So could you go over the rules for knowing the radian measure of the unit circle?
Like the different measures, you mean, or like how we know where they are?
Like with quadrant 4. In quadrant 4, it's like 1 less than double.
Yes.
But 1 less than double of what? And like
1 less than double of the denominator.
Oh, okay.
Mm-hmm. Yeah, because going the full distance around here, Jeff, would be 2 pi. So that's like exactly double whatever your denominator would be.
The denominators always. Is there a rule for the denominators?
It goes 6, 4, 3, and then 2 at the top, and then it goes 3, 4, 6, and then back to the bottom kind of thing. So.
Yeah, is there a way I can just like remember 1 and then like use that as a base and just like add it over to itself?
Yes, but let's hold off on that right now because right now we're going to do this, okay? But I can help you with that later, okay? Yes. Okay, so back on track here. So we still need to come up, though, with the x and the y values. Now, we have just drawn, right? We just talked about the special right triangles in our little trig cheat sheet here. However, is our 30, 60, 90 right triangle the same as the 30, 60, 90 right triangle that we have drawn right here? No. What is different about it? Yeah, the hypotenuse here is 2. The hypotenuse here is 1. So these triangles are going to be similar because they all have the same angles, right? 30, 60, 90. But the difference is it's the scale, okay? This one has a hypotenuse of 1. This one has a hypotenuse of 2. So in other words, we have to halve the distances, okay? So opposite the 30-degree angle here is our y coordinate, okay? Opposite the 30-degree angle here is 1. So that means what should our y coordinate be for this one? 1 half, okay, by similar triangles, right? We have to take our, our 1 there and do it, by half of it, okay? And then opposite the 60-degree angle, opposite the 60 degree is root 3, okay, in our normal triangle with hypotenuse 2. But then if we want to scale that back to a hypotenuse of 1, root 3 over 2. Okay, exactly right. Root 3 over 2. Okay? Root 3 over 2. Alrighty? So that gives us our coordinates. Now, why is this significant? Well, if we take a look, for example, again, talking about our unit circle here, if we imagine trying to do like the sine of 30 degrees, okay? This kind of connects back. Oops, I'm off the screen. Here we go. Zoom out some. There we go. Okay, if we wanted to find the sine of 30 degrees, for example, okay? Well, let's use this, again, this special right triangle right here. Let's use this, okay? Where the x is root 3 over 2 and the y is 1 half, okay? Sine, according to SOHCAHTOA, is what over what? Opposite over hypotenuse. So sine of 30 will be the opposite leg, which is 1 half, over the hypotenuse of 1. So it's just equal to 1 half. Okay? Using that. Yep. Question?
Could you so how did you get the 3 over
The root 3 over 2?
Yeah.
So it has to do with comparing our 30, 60, 90 right triangle that we have in the unit circle to the 30, 60, 90 right triangle that we talked about on our circle that we drew. And where did I put it? Here. Okay? So here's our 30, 60, 90 right here. Okay? Its hypotenuse, though, is 2, which means this triangle is twice the size of this one right here. You see that by similarity's sake. And so, therefore, then, when I see opposite the 60-degree angle here, I said it was root 3 over 2, because opposite the 60-degree angle here was just root 3. So, in other words, since my hypotenuse, I have to have it to get that, right? I have to have, or divide by 2, my root 3 in order to get the root 3 over 2 there. And then same thing here, opposite the 30-degree angle, there is 1/2, because, again, that's half of the 1 right there.
Okay.
That's it. That's all we're doing. Scaling it back. Okay? Okay, very good. So then we could also do, for example, here, cosine of 30 degrees. Okay, what would cosine of 30 degrees be here in this case? Well, cosine is the what over what? Adjacent leg over the hypotenuse, so it's going to be root 3 over 2 over 1. So just root 3 over 2. Okay? So you see, both that 1/2 and the root 3 over 2, they show up as the x and the y coordinates there, right? So the cosine of 30 ends up being the x coordinate where that's located by that 30-degree angle. And the sine of 30 degrees locates the y coordinate there. Okay, so you can kind of see they associate there. So it's like the x, and there's the y. Right there. Okay, oops, equals, forgot the equals sign. All right, so let's continue, right? What's our next angle after 30 degrees on the unit circle there? What's the next one that comes up? 45, or in radians? Pi over 4, right? So let's go ahead and take a look at that one. Okay, so then I'll draw another one right below it here, just so we can highlight that particular angle. Okay. Question, Jeff? Yes. Yes. Mm-hmm. Okay, very good. All right, so for the 45-degree angle, or pi over 4. Okay. Oops, there we go. Okay, again, we're going to try and get coordinates for this point that 45-degree angle, or pi over 4 angle, radian angle, locates for us, right? So it's going to be further left than root 3 over 2, so it's going to be a little bit less than root 3 over 2. It'll be a little bit more than 1/2, though, right? Because we're a little bit further left, but we're a little bit further up, too. So, again, comma, blanks there. And so, again, drop down a vertical line here, and we create a right triangle. But now what kind of special right triangle do we have here now? 45, 45, 90. So this is our x-coordinate. This is our y-coordinate here. What do we know about the hypotenuse of this right triangle? It will also be 1, right? Because, again, it's connecting the center, bless you, to a point on the circle. Okay. All right. Now, furthermore, though, what do we know about x and y here? They're going to be equal, because what kind of triangle, besides being right, it's also what? Not equilateral. Isosceles. Yeah, bless you. Very good. Okay. Yes. So once we find x or y, the other one will also be the same thing. All right. So again, let's go to that special right triangle that we have. Put it right here. Okay. So in this case, and again, depends on which one you want to use here, as far as like, you know, I think it'll be easier to use like the parenthetical one, I think, too. So let's say we use the hypotenuse of 2 here, right? So what do we have to do then to make that 1? Well, divide by 2, right? So then this leg of root 2, the leg of root 2 right here, right? We can divide that by 2 and make it root 2 over 2. So this is going to be root 2 over 2 there. Again, just by similar triangles. Okay. Alternatively, we could use, you know, these measures right here, the root 2, the 1, and the 1. Okay. And so in other words, to make root 2 become just 1, you'd have to divide by root 2. So alternatively, you could take the 1 and divide it by root 2, 1 over root 2, but that is the same thing as root 2 over 2 when you rationalize. Okay. And so this one also is going to be root 2 over 2 by the same argument. Okay. So I'll say it one more time here. All right, I'll go through it one more time. So again, we have our 45, 45, 90. I can put that up here too. Okay. Correct. Correct. Which rationalizes to root 2 over 2. So they are equivalent. But I see what you're saying, Ro. So I use, like, so it's more obvious if you use, like, the parenthetical measurements that I gave here. So if you say the hypotenuse is 2, and then this would be root 2 and root 2, then it's easier to see, oh, I have to take this parenthetical hypotenuse, divide it by 2 to get the 1, and so then these parenthetical leg lengths, divide those by 2, you get the root 2 over 2. But you're right, Ro. If you did the same thing with the root 2 here, divide it by root 2, then it'd be 1 over root 2, 1 over root 2. But that does rationalize to those two things. Okay, so again, if I choose here to do, for example, sine of like pi over 4, okay, I can use this little, special right triangle here. Okay, sine number is again opposite, so it's the y coordinate over 1, right, which will just be then root 2 over 2 over 1, which is then just the root 2 over 2. Likewise, cosine of pi over 4, okay, it's equal to the adjacent leg, which is really the x, over the hypotenuse of 1, which is then just going to be, again, root 2 over 2 over 1, which is just root 2 over 2. Okay? So, yes, question?
Is tangent going to be y over x?
Yes. Yes, yes. What do you remember that from algebra 2 or something then? Yeah. Yes, tangent. And we're not going to worry about tangent right now. The first quiz that we're going to tackle dealing with this kind of stuff is just going to be sine and cosine, and only in the first quadrants. First two quadrants, I mean. And then we'll add all the other trig functions, including secant, cosecant, and cotangent too. Okay? Whew. All right, we got one more big angle we got to worry about in the first quadrant here. And then don't worry, we won't spend this much time on all the other ones. It'll just be using like reflections and stuff like that to help us with the rest. So the last angle is what? 60 degrees, and radians? Pi over 3. That's right. Okay, so again, draw one more quarter of the unit circle there, and we'll put the 60 degrees right there. Okay, of course, or pi over 3, like we said. And again, I'll drop the vertical down and put the little right angle marking in there. Okay, what is the hypotenuse of this particular triangle going to be? 1, right? Again, it's another radius. So we can go back to our special right triangles here, okay? So again, the hypotenuse is 1, which means I have to take my special right triangle relationship here and divide all those sides by 2 for the similarity. Okay, so what will this leg be right here? What measure will it be? It's opposite the 30-degree angle. So if this is 1, this one will be what? 1/2, yeah. Okay. And if this one here, the long leg, was root 3, then that means this leg will be what? Root 3 over 2. Exactly right. And so our coordinates are... Okay. 1/2, and then the other one will be root 3 over 2. Okay. And so those are our coordinates for that one, using similar kind of argument. Okie dokie. And so again, if we take the sine of pi over 3, okay, sine is opposite, so that's like the y coordinate there, over 1. And y, the y coordinate here is root 3 over 2 over 1, which is just root 3 over 2. Okay, and then cosine of pi over 3, that's the adjacent leg, so it's x over 1, which is 1/2 over 1, or just 1/2. All right. And so, let's take a look then at how we'll fill out quadrant 2. All right, and let's see, can I fill it in? I think I'm going to try and fit it in here, if I can. So I'll put that right down here. I think I can fit it in. Yep, I think I can do it here. So then what about quadrant 2? All right, I'm going to just fit that in right down here. So I'm going to draw quadrant 1 and quadrant 2 kind of simultaneously here. Oh dear. Okay. So again, unit circle continues on around. Okay, and I'll just kind of regurgitate some of the coordinates there. So there's, here I'll go zoom in some there. So 1, 0, right, and then here at 30 degrees or pi over 6, we have the coordinates of root 3 over 2 comma 1/2. Okay, and then here at 45 degrees or pi over 4, we have the coordinates root 2 over 2, root 2 over 2. And then up here at 60 degrees or pi over 3, we've got 1/2 comma root 3 over 2. Okay, I didn't mention this coordinate up here at the 90-degree angle or pi over 2. Yeah, but what's the coordinates for this? 0, 1, yep. Exactly right. Okay. So now let's do an easy one over here in the second quadrant. Let's do this one here at 180 or pi radians, right? What's the coordinate for this point going to be here? Negative 1, 0. Yeah, we're 1 to the left, so negative 1, 0 there. Okay, that's an easy one. Okay. The next one, if we go now, let's go clockwise. We're going to go backwards, kind of. We're going to go backwards. The next one is going to be, well, what is it? Do you remember? What's this angle if we go back here? It's 150 or pi, 5 pi over 6, right? Okay. Now, you can think of, okay, 150 degrees or 5 pi over 6, right? How are we going to create a right triangle from this? Because 150 degrees goes all the way around here, right? You can't create a right triangle with a 150 degree angle. What's that? Right. So yeah, don't think about this necessarily as being a 150 degree angle. You could, right? I mean, that's true. It does get us that position. But alternatively, if we go back 30 degrees here from the 180, we are now at, yes, a reference angle. Yes, it's like it's basically like a reference angle is like the angle that's closest to the x-axis. That gets you, like the angle that takes you to the x-axis, the closest, the fastest, I guess, whatever. Like the closest to the. Oh gosh. Okay, sure. You can think of it that way. Yeah. Yep, that's one way to think about it. Yeah. No, it's true. Yeah. So yes, exactly right. So we're not going to evaluate this like it's a 150 degree angle. Instead, we're going to treat it like it's really a 30 degree angle off the axis, which then creates a 30, 60, 90 right triangle here. Okay. You can also see that this 150 degrees is a reflection over the y-axis of what other angle? The 30. Okay. So now, what will the coordinate then for this point be? And I didn't leave myself much space. I'll have to kind of like draw an arrow here. Okay. What will the coordinate be for this point then? Negative root 3 over 2. Positive 1/2. Yeah. Okay. So this 150 degrees, or 5 pi over 6, which is exactly 30 or pi over 6 away from our x-axis, has the same numbers as our 30 or pi over 6 angle in the first quadrant, root 3 over 2 and 1/2. Okay, the only thing that changes is whether it's going to be positive or negative, right? That's the only difference. All right. let's go back this way as well. What's the next angle before the 150? What comes before 150? 135, or in radians, 3 pi over 4, right? Okay. Again, 135 is the distance in the counterclockwise direction that we're going, right? But what's the distance from the x-axis, really? What angle measure is this? 45. So we have a 45, 45, 90 that we create there, okay? All right.
Today. And two,
Yes.
we want you to go get your snacks that are in the conference room. And Mr. Mills is going to teach for 5 minutes.
My snacks that are in the
And they're
conference
snacks
room.
for American education.
Oh, really?
And they're all homemade treats. And we know you would want to get first dibs at them and not wait till 4th block.
I can wait, though. It's
I don't
really
think you
okay.
can.
Yeah, it is the trigonometry stuff. Okay, okay, thank you. I appreciate it. I do like my snacks. So, all right. So back to what we were working on here. Okay, so right. So what would the coordinates for this point be? Well, it is a reflection, right, of just that 45 degrees. So it's going to be negative root 2 over 2, comma positive root 2 over 2. Okay, and then the one more before it, right here, it's now 60 degrees back, so we're talking 120 degrees, or take away a pi over 3 from pi, we're at 2 pi over 3. Okay, and then that angle would be negative 1/2 positive root 3 over 2. Okay, like so. And there we've got the coordinates. Now, what are the purposes of these coordinates, right? Why do we bother looking at them and writing them down? Well, because if you remember from when we were evaluating things earlier, right, the sine always ended up being our y coordinate over 1, because the hypotenuse was always 1 in our unit circle, and so the sine of an angle is just the y coordinate. The cosine of an angle will end up being just its x coordinate, okay? And so now, if you want to take the sine or cosine of any one of these angles, okay, you need to only look at, for the sine of one of those angles, you look at the y coordinate. For the cosine, you look at the x coordinate, and that will give you the value there, okay? Now this is not, this is one way to kind of relate things. Again, there's many different ways to kind of enter into trigonometry and like learn this stuff, okay? So, and it's all kind of interrelated. So anyway, don't fret if this is like overwhelming to you and you're like, whoa, how am I supposed to like get this down for a time trig quiz? I will show you a like a kind of a way to kind of organize your thinking, I think. That'll be helpful, but for right now, I just want you to kind of get down, try it on your own here a little bit with this stuff, okay? But this is all that we are, all that we're going to be doing today. This is it, okay? We've just stopped right here. So what will we be doing now? Well, I'm going to be doing like something like this. I'll ask you, for example, what is the sine of 150 degrees, for example? Okay, now this is something you could type into your calculator, right, and get an answer, but we can also now know precisely what the value is going to be. We'll go to 150 degrees on our unit circle, right here, okay? We know that sine will be the y coordinate of this point, so sine of 150 degrees, 1/2. Okay, let's say we want to do the cosine of pi, okay? Pi, which is in radians, right? No degree symbol, so radians. So pi is over here, okay? And cosine, remember, we associate with the x coordinate, right? And so what is cosine of pi going to be? -1. Okay? And then you can go from there. All right? So this is your little cheat sheet you can use to help you evaluate those things, the unit circle stuff. Okie dokie. Let's see here. So what I've got for you then is one of these little coloring pages. You don't have to do the coloring if you don't want to, okay? But there are different trig ratios for you to find, only sine and cosine, and only in quadrants 1 and 2, okay? Oh, wait, never mind. They go into 3. Okay. Some of these go beyond that. Did I do the wrong thing? Let me see here. Maybe I copied it too soon. Let me see. Yes, I took a step ahead. Oh, okay. No, I just went ahead and okay, that's what I did. Never mind then. Okay. So let's go to our page one more time here today. Yeah, we're just going to fill out the rest of the quadrants, I think.
Before you move on,
Yep.
I have no idea what's going on. Why is like, so like I understand where they are in the unit circle and stuff.
Uh-huh.
But what I don't get is when, like going back to the beginning, like when you do sine, like angle 45 or something.
Uh-huh.
You
Oops.
get 4 over, or y over 1. Like,
Where'd that come from?
yeah.
So the little reference triangle that we create, the triangle that we create right here, right, with the 60, the 30, and the 90, right? If I do sine of that pi over 3 or 60-degree angle right there, right? Sine in our right triangle here, right? Sine is the opposite leg. So this opposite leg is this one right here, right? What is this though? It's the y coordinate, right? It's like that y value, right? It's the height off the x-axis here. So it's that y value over, and then, well, the hypotenuse of 1. So it's like this vertical height, which is a y value, over the hypotenuse of 1 there. And so that creates that. So in other words, it's going to be just y over 1, or just the y coordinate of this point, which is root 3 over 2, because of the unit circle. Okay? So, yes?
Can we draw our reference triangles on the quiz?
Yes, you will be able to do that.
Like before it starts?
Yep, I'll let you do that, yes.
I get confused how you found like the first triangle we did with the 30-degree. I remember 6, how you got the x and y coordinate.
Okay.
I just got confused on how you got root 3 over 2 and 1/2.
Okay. So what I'm going to do here is just fill in the rest of this unit circle, and I'll help you here, Jenna. Sorry, I'm not ignoring you. Okay. So you can fill in all these coordinates on your unit circle here. I'm going to do it myself. Whoops, Mr. Wade. Okay, like that. Yes and no. It depends on the method that you choose to evaluate this stuff. Okay. So, there's those first two quadrants. Okay. There's those first two quadrants. Imagine then reflecting them down. What's going to happen with all of our y coordinates? They'll become negative, and all the x coordinates will stay the same, right? So just flip it down, and that'll give you the rest of your coordinates there, okay? So 7 pi over 6 is going to be a reflection of that negative root 3 over 2 comma 1/2. So it'll be negative root 3 over 2 comma negative 1/2, okay? Okay. And then we'll have negative root 2 over 2 comma negative root 2 over 2. And then we'll have negative 1/2 negative root 3 over 2. And then here at 270 will be 0, negative 1. And then bless you. Okay? And so there are your bottom coordinates and stuff like that. Okay? Okay, so now you can fill out the quilt. Okay. Let me get this video started here. Or finished, I mean.